Hello, good evening. Can you hear me?
Yes, Assalamu alaikum. Good evening. You're
Wa-
here.
Walaikum assalam. Hope all are well. Yeah. Okay, so basically today is our seventh number class, and I hope you already do learn a lot of things from this training session, and also try to publish some scientific paper regarding this type of topic. Okay, so I already check your paper. You send me monitoring and instrumentalization trend in western area of Sierra Leone. Okay. So it's also okay, no problem. We try to publish this type of paper. Okay, let me share my screen. Okay, can you see my screen? Is it visible?
Yes, please.
Okay, thank you. Okay, so you try to write monitoring and assessment evaluation trend in the western of Sierra Leone. Okay, all figure is good, not much any problem. Okay, so basically today I try to discuss about some other topics, mainly how we can easily work with deforestation, okay, using machine learning. Different types of machine learning were used for making the different types of land use land cover classification. But for deforestation, we can easily use the support vector machine. Okay, suppose I have a forest area. So for this forest area, I want to monitor the deforestation area. Okay, so then we can easily apply the machine learning. It can be historical, no problem. We can also use the Landsat satellite imagery for that. Okay, we also discuss about that. And then it also including the illegal logging area. Okay, suppose deforestation, this type of topic you can also connect with the illegal logging areas in the forest area. We can also identify this type of illegal logging area using the deforestation method. We can easily identify. Then we talk about the slope classification. Okay, suppose how we can easily, just a minute. So how we can easily compute the slope and also make the classification of slope. Okay, different types of range, and then further we simply calculate the area. Okay, then we talk about the NDVI classification. Basically, how we can easily make the NDVI. We already know about that. So based on the NDVI calculation, we also calculate the density level of vegetation. Okay, and how we can easily calculate the area of each density level. We also discuss about that. And then we talk about that raster value extraction from GPS point. Okay, so that is we try to discuss about that. And from the next class we discuss about the bioclimatic variable. Inshallah, for the next class we discuss about this type of topic. So today we discuss about the deforestation, slope, NDVI calculation, and raster value extraction from the GPS point. So here I already show you write the code, show you some my previous project. Suppose this is the one kind of deforestation project for the mangrove forest in Bangladesh. So if you check in this deforestation, you can easily identify different types, mainly year wise. So every 5 years interval, we try to identify, suppose 1990 to 1995, how much area deforestation we try to identify. Then 1995 to 2000, how much area. Then 2000 to 2005, how much area deforestation we try to identify. Then 2005 to 2010, how much area. Then 2010 to 2015, we identify. Then 2015 to 2020, and finally current forest. Okay, so this is the current forest we try to identify. So this is the historical data analysis of deforestation. So if you check the map, suppose this is the forest area. So we can identify, you can see this is the forest 1990. So in 1990 we find out this type of place was forest. This is the result for 1990. Then 1995, this is the forest area 1995. Okay, then if you check forest area 2000, year of 2000, then check 2005, 2010, 2000, 2020, okay, forest area, and 2015. Okay, so this type of forest area you can easily identify. And how I can find out this type of forest area? So I'll try to, and this is the forest year. If you check, okay, so you find out, so it's loading. And this is our final output. Yeah. So this is the final output. We find out that you can see current forest. So basically this type of green color indicating about the current forest. Okay. And if you check this type of color, so different types of deforestation pattern for the yearly, different types of year. Suppose 1990, 92, 95, here we find out the deforestation. Okay. Suppose you can see we find out this type of place, we find out the deforestation in the between this time period. Okay. Then 1995 to 2000, we find out that this type of color indicating about the deforestation. This type of place, we find out the deforestation. Then 2000 to 2020, 2005. Okay, so this time period we find out that this type of place was deforestation area. Okay, then 2005 to 2010. So it's create the 1, 2, 3, 4, 5, 6 total different 6 class and also current forest information. Well, this type of green color again about the current forest. So now what the method I try to use for that? So in this case we must use the Landsat satellite data to identify forest year. So if you check, this is the surface reflectance data, mainly satellite image, surface reflectance satellite image in 1990 for this forest. I simply filtered this data yearly 1990. Then if you check the data for 95, so this is the 95 satellite data. Okay, then this is the data for 2000, then this is the data for 2005, then this is the data for 2010, and this data for 2015 this is the data for 2020. Okay, so this is our data. So different time Landsat imagery 1990, then 1995. So every 5 years interval we take the data from here. So after getting the data, first of all we identify forest area. Okay, suppose for every year you can see for the 1990 we compute the forest area, and it's called the vegetation index. We calculate the vegetation index. If you check, so this is the vegetation index, mainly NDVI. You already know about that, NDVI or EVI. So we are using here the different types of vegetation indices to identify for vegetation. So this is the vegetation indices map for 1990, and from this map we just identify forest area. So we find out this type of place was forest. We can identify forest area. You can see forest for 1990. So same process also apply for 1995. So this is the image 1995, and we calculate the NDVI using this image, and then we identify forest area. Okay, only for the forest area we try to identify. So this is the forest area we identify for only for this year in 1995. Then same process 2000. Okay, 2000, then 2005, 2010, 2015, 2020 we identify. So let's go try to explain the code one by one, then you can get the more better idea, okay, about this code. So first of all, we simply imported Landsat 4, Landsat 7, Landsat 9, Landsat 8, Landsat 5. We simply imported this type of, okay, just a minute. Let me, okay, suppose my disk is full. Let me remove some file from my disk. Otherwise, record is not possible. Just a minute. Okay. Okay, so now I hope it's okay. Yeah. Okay, so just I try to explain the code, then you can get the better idea how we can easily work with deforestation for the different time period. So now we simply imported the different types of Landsat image collection. Suppose Landsat 4, 7, 9, 8, 5. Okay, and this is my study area. And here we simply make the list. Okay, suppose you can say I simply put the list all of year which I need. Suppose in this case, I simply put the list 1990, 1995, 2000, 2005, 2010, 2015, and 2020. So you can simply import your own requirement time period, then simply import. And then we simply use the filter to function to filter. So in this case, we create a function. Basically, we create a function. In this function, we simply set the one element, suppose collection, then another suppose ROI, another suppose date. Okay, and we simply use here that return this collection filter date basically date 0 and date 1. So we just identify the date after some time, then filter bounds with ROI. So we create a function for filter. So we create a function for filter. So this is the another way. It's not the all time we'll just follow that, but if you want you can also use this type of technique. Suppose in this case I just give a variable name. Suppose I put the variable name, suppose filter collection, and I put the function variable name. This is the function variable name, and then equal same. So I create a function variable name filter collection, then equal function keyword. In this case, I simply apply the three element. It's a three element. Suppose collection is one element, ROI is the another element, and date is the another element. So what I return from this function, I want to return this collection filter date by date. Okay, this date I already defined the date 0 and 1, basically first and second, basically start and end. Just put the two date 0 and 1 and filter bounds with ROI. So this is my function. So this function help me to filter my collection. So this function further we also use. So if you check this function, I simply use in here. Okay, and I simply define here. You can see collection L4 is one kind of collection. ROI basically it's my study area. okay, this ROI, and then date, and simply merge same function with Landsat 5, ROI and date. Okay, so Landsat 4 and Landsat 5 we simply merge, because all of Landsat 5 and Landsat 4, all of spectral signature bands are similar. Okay, so simply make the merge between Landsat 4 and Landsat 5. And how I can make the composite? Just help of filter collection function. So I create a function, suppose it's one kind of tool. So this tool help me to filter my collection. My collection is 4. L4 is the one kind of collection, Landsat 4 collection. Then ROI, it's my boundary, and date. Okay, and we simply merge. So Landsat 4 and Landsat 5, both of collection we simply merge after filter. Okay, so after filtering, and how I can filter? I just use this function. And filter Landsat 4 and Landsat 5, and then both of collections simply merge. After merge, I simply create the median composite, okay, and clip with my study area. And we also get the another function, cloud marks TM. So basically this function help you to remove the cloud from your satellite imagery. Okay, basically this function, cloud marks TM. So it also better, this function, it also better, we can just put up the code. Suppose just I simply copy the function cloud. Basically this function help you to remove the cloud from the Landsat 4 and 5. So just I simply paste before the line of the code, it will be more better. Just I paste here. So now this is my function. This function basically help you to remove the cloud and cloud shadow from your satellite imagery, and also reproject the scale factor. So simply multiply the scale and also add by offset value. All about, we simply select this type of bands. So now this is the function I simply call and create the median and clip with my study area. So if you check, in this case, I also create the another function. Okay, I create the another function. Suppose my function variable name is the Landsat 457. So this function, this is my function variable name. I simply store it, this all of those you can see. So just I create a new function. I put the ROI and date. So this ROI and date is my element. And what is my argument? My argument is I just simply make the merge between Landsat 4 and Landsat 5 collection after filtering. And how I can filter? I just apply this function and filter. So further just simply call this variable name filter collection and then create the merge. So simply filter the Landsat 4 and Landsat 5. So Landsat 4 and Landsat 5 simply merge Landsat 4 and 5. And then this collection just connect with the cloud marks function, okay, and create the median composite and clip with the study area. And what I return from this function, I return the image. So same, we are just create the another. Suppose just I copy, this is my function variable name. So this function I simply connect with the Landsat 8 and 9. Okay, just I simply call the filter collection function. This is my filter collection function. It just come from here. So this filter collection function I simply connect with the Landsat 8, okay, and then ROI and date and merge with Landsat 9, and further apply the cloud marks function. This is the cloud marks function for Landsat 8 and 9. So just I copy the code and paste above the code. Again, just I paste here. So this is the function variable name, mainly removing the cloud from the Landsat 8 and 9. Okay, just this is the function variable name. If you check, this function variable name is the cloud marks OLI. So this cloud marks OLI simply connect in here, again median and clip. And this thing we also create a function. So we create the two function, Landsat 4 5 and Landsat 8 9. So these two function further you also use, okay, further you also use to create the annual NDVI or annual deforestation for checking. So now it's work as a function, Landsat 457 and Landsat 8 9. So this function when I use, I need to define the study area and define the time. Suppose I just work the Landsat 457, this is my function. So this function have a two argument, ROI and date. So ROI basically study area and date we simply define the date. Okay, so this is the collection of function. We simply create different function. Landsat 457 have a one function, and Landsat 8, 9 have the another function. Okay, so now we create the annual image. We create the annual image. So generate the image per year. So further we simply apply ee.image collection. Okay, and we already defined the year of list. If you check, year of list basically stored the list all of year 1992 2020. So all of year basically stored in this variable year list. So just I simply define here year list, okay, and create a function. So in this function we simply define the start date and end date. Start date, end date. So basically we simply define ee dot from year, month, day, year minus 1 first month, first date, and then plus 1 end year, plus 1 December, mainly last month, and 31. So we define, and then date we simply start and end. So simply define the start and end. Okay, so this is the way we simply create a function. You can see we just create a function in here also again. So in this code basically we just use the different types of function. Okay, this type of things if you can also do the manually. It also possible, but it take lot of code we need to write. But when you apply the function, very few of code we simply write and do. Mainly this type of code we can simply reuse again and again, and then we can easily apply. So in this code, first of all, we just simply create the function. So now we simply define the some condition. Suppose year of 2014. Suppose I need the image year of 2014. So now this year of 2014 image year, you can see year less than 2014, and I put our argument Landsat equal Landsat 457. Or if the image is not available in the Landsat 457, then it just take the image from Landsat 89 collection. So basically it's my collection. Okay, Landsat 457 and Landsat 89, if you check these two variable, it work as a function. It's work as a function. So this function is stored the image merge of Landsat 8 and Landsat 9, and this function merge of Landsat 4 and Landsat 5. Okay, so we simply put the condition. Suppose in Landsat, suppose I need the image 2014, or I need the image less than 2014. Suppose I need the image less than 2014, and this image if available in the Landsat 457 this function, then it take. But if there is any way, suppose this image is not available in the Landsat 457, then it simply go to the second step, because it is if condition. If the first statement is not true, then it go to the second statement and find out the image. Suppose in 2014 between this collection there is no image, then it simply jump to the second collection and find out. And if the image suppose first Landsat 457, then it not go the second statement, not need to check the second statement. So this type of things. And now we create the image composite. So just we call the Landsat, okay, and define the ROI and put the date. And for we simply put here, you can see the this is the visualization parameter of the image. Okay, and we simply set that band, also calculate the visualization index. Okay, you can see expression near infrared minus short wave infrared plus near infrared plus short wave infrared, then put the visualization index. You can put any formula. So in this time it show this type of formula, but if you want you can also put the EVI or others different types of vegetation. In this time we saying about put. And now forest, how I can identify forest. So forest basically we take the high value of vegetation. So in this case we take the value greater than 0.7. Okay, greater than 0.7, mainly dense vegetation. So this dense vegetation we just consider as a forest. So just put the greater than 0.7. So because this is the dense forest we identify, and we just add the forest layer as a green. Okay, forest layer as a green. And then forest area we also compute in here. So forest area we just compute into a square kilometer unit and multiply area unit. So it's create a function. If you check, it's create the full function. So all of those we simply connect with the function. Yeah, please. Yes.
Yes, if we take 0.7 for dense vegetation,
Yeah.
The 0.7 for the dense vegetation, is that applicable all over? Is
No.
it also applicable for a region?
No, it's not applicable. It's not the standard value, but mainly greater than 0.7 or 0.6. Some place we find out the 0.6. It's indicating about this mainly dense vegetation for the forest. For the forest, we can use here the 0.6 to 0.7, 0.6 to 0.7, greater than, okay, greater than 0.6 to 0.7 is a standard value for the forest area, mainly dense forest area, because forest have the different types of forest. Some forest have the low vegetation or not much dense vegetation, then this value you also need to change. Otherwise we just simply use 0.6 to 0.7 for the any dense vegetation. Okay. Okay. And it also calculate the area of chart to identify for forest area for the different time and at the legend. So you can see very short code, not very much code. You can see just from 1 to 133. Okay, but in this code it just work lot of things at the same time for Landsat 4, 7, 8, 9. So all of image collection. Further you can see it also help you to add all of image, all of band. You can see for the SR bands, all of image for the different year. Okay, and then all of images vegetation index, and also add the all of images forest area. We find out this type of place is greater than 0.7, vegetation index value 0.7, this type of place. Okay, in 90 in 90 we find out the 0.7, this type of place. Also same you can see this image is, this function also help you to identify vegetation. Suppose 90 so we find out this type of place is vegetation 90 okay, 0 greater than 0.7 we find out. So up to all of those it calculate. So this is the one kind of very powerful code, because in this case we are just use only for the function, and function mainly help you to reuse your code again and again. So you can see very short code, we can simply make lot of analysis we can simply do in here. Okay, as well as you can see it also added the legend. Also you can see the chart, all of those all of year, calculating the area, and also you can see 0.7. So all of those we simply consider as a function. You can see this function start in here and up to you can see the last in here. Okay, so all of those we simply including in one function. Yeah, please. Yes.
Yes, when we use, for instance, 2014, if we
Yeah.
said if we don't have image in Landsat 4, 5, and 7, then we can use Landsat 8 and 9.
Yeah.
So now go down a little bit. Go
Yeah.
down a little bit. If go down, please. On the years, if let's say 1990 there is no image, 1991 there is no image, can the other years replace the images like we are replacing Landsat and others?
Yes, so if suppose some year is not image this type of place, then it will be simply automatically replace. Okay, suppose Landsat 4 and Landsat 5 there is no image for 1991, then it automatically move to the 92 and take the result from here. Okay, and in this time it show a
Yes,
problem.
I can see here 1990,
Yeah.
1995, 1995 to 2000. All right, okay.
Yeah. Because in this time you can see, suppose this it create the total 5 years. Suppose from the 5 years any 1 year is not have any image, so then it just skip and then make the composite or make the analysis between the 5 years image analysis. Suppose in the 1991 there is no image, then it's not a problem, because in this time we take the date frames from 1990 to 1995, this time, this year, between this year. And it show the problem because there are a lot of pixel, too many pixel in our region. So for that we need to increasing the pixel size, then the chart will be appeared. So let me show you that for the chart code. This one. So just I simply suppose put here the 100 and then check what happened, and it create the yearly chart, mainly area, deforestation area we find out from the chart. Suppose 1990 to 1995 how much area deforested we find out, then 1995 to 2000 how much area we find out, it computed. And these are visualization of our map for the different year for the scenario of the deforestation area. it's loading because there is a lot of data set including. Okay, so you find out, you can see. So now you find out this type of chart for the forest area change. You can see this is the result. Okay, deforestation area for every year you find out this type of result, mainly 5 years interval. And you know, download the data and get the result. So this is the one kind of deforestation map, but you can see we are not apply any kinds of machine learning. Okay, we are not applying any kinds of machine learning. We simply work with the vegetation index for the different time period, and we set a pixel value, suppose greater than 0.7 or 0.6, and then identify for the forest area or change the vegetation area. But it also possible we can also use a machine learning model. Okay, so it's also helpful for the machine learning model. Suppose if I show you the another example how to use the machine learning, identify deforestation and forestation area, then you can get the more better area. So if you check, this is the another code. So in this time we need the training sample. Okay, suppose any vegetation area, suppose this is my satellite imagery, Landsat surface reflectance satellite imagery. So this satellite imagery, I have suppose this type of training polygons. So you can see this is the training polygons. Suppose forest area and non-forest area. So this type of, so this is the training sample for the forest area. Let me zoom. So you can see this type of place is the forest, mainly green color. We consider the forest. You can also use the another band combination to look more better. Suppose let me show you that. Suppose I put here that short wave infrared 1, then near infrared, and look custom stretching 90%. So in this case, it's called the machine learning method. But previous time we are not use the machine learning. We are just use the values. Okay, NDVI pixel and identify for deforestation area. So if you check, we find out. So this type of green color is the forest area. Okay, but you can see this type of color. This type of color is not the forest area. It's the deforestation area identify or barren land. Okay, in this case, my target is that I want to identify forest area and deforestation area. Okay, suppose this type of green color indicating about the forest area, and this type of color indicating about the deforestation area. So I simply take the polygon. Suppose this polygon is for the forest and also this polygon is for the forest, but this type of brown color, it's not the forest, so it's a non-forest area or deforestation area. After that, we simply make the classification and identify deforestation area. Okay, forestation and deforestation, both of area we can just make the classified. If you check, so we find out this type of green color indicating about the forest area, and this type of yellow color indicating about the deforestation area in this forest. So in this case, we are just applying the machine learning model and identify this type of thing. So let me try to show you this type of code, then you can get the more better idea how to apply this type of code. So in this case, we are applying the support vector machine algorithm because this algorithm is very popular to work with binary classifier. Many binary classifier, mainly possible outcome only for the two. So it's called the binary classifier. We can simply apply the binary classifier and then make the classification about that. So first of all, if you check the code, so basically this is the code mainly help you to remove the cloud, okay, from your satellite imagery, and also replace the original bands with the scale bands values. Okay, we simply use this. So this is the one kind of function. Okay, basically it's help you to make the more better image. So it's a function. If you want, you can also write the function this way. Take a variable and put the function variable name, then equal sign. So this is my function variable name. Basically, this function mainly help you to make the Landsat surface reflectance imagery. Okay, mainly when remove the cloud, mainly cloud or cloud shadow, and also applying the scale factor. Scale factor basically offset value or scale value. Okay, this type of thing simply connect in this function. We already know about this code or function. This function basically help you to get the very neat and clean satellite imagery, and also reflectance, get the digital number convert to reflectance value. So we simply connect this function. You can see this is the function variable name, simply connect, and this is the Landsat surface reflectance collection. So this is the time period, we simply put it here, and we create the median composite, and in this time we are just apply this type of band for the prediction band, SRB2, SRB4, SRB5, SRB6, and SRB7. We simply put in here, and this is our if you want, you can also draw the rectangle, no problem. Simply click on here and draw the rectangle for your forestation and deforestation area, or if you want, you can also put here value, rectangle value. Okay, rectangle value, simply put that this is the rectangle value. Okay, this is the another, this is the another, this is also. We simply put the value. That was forest, we take the two polygon, forest and forest 2 for the forest area, non-forest 1 and non-forest 2 for the non-forest area. We simply take, then simply merge. So we simply create a feature collection, you can see. So simply put the feature collection. So this is the feature, it's mainly feature, but when I add the attribute, suppose I put the attribute class 0 and also class 1. Okay, class 0 basically non-forest training sample, and class 1 basically forest training sample. So when I add the attribute, then it work as a feature collection. Okay, I stored it in the polygons in here. So further simple process we simply apply. So we simply apply the extract the band pixel value for each polygon with the training point. Simply apply the sample region function and call the image and put the sample regions. Then put the collection. Collection basically it's my polygons, same as like land use land cover. We already know about that. Just copy the polygons. Properties is the class. Simply define the class and set the pixel, mainly your satellite image resolution 30 meter. So this is the training. Okay, training data set. If you check, suppose print and call the training. So now all of polygons extract the band pixel value. So if you check this data, okay, show the, okay, it's about the 5000 element. Suppose I need to check for the first data. I need to check. So we find the first is feature. If you check the first feature, there are 20 properties. We find out all of values. We find out. Okay, so basically it's our training data set. Okay, our level is the 0. 0 mainly, if you check, we already said the 0 mainly deforestation and 1 mainly forestation area. 0 mainly deforestation, 1 mainly forestation. Okay, so we find out this type of property. It's our property, all of property, mainly band pixel value, this type of polygon. Okay, and now we just create a classifier. So basically it's a binary classifier. Mainly we just classified only for the forest and deforestation. So for the binary classifier, it also better to use the support vector machine. Okay, support vector machine. If you check suppose on the Google, then you can get the some theoretical example about the support vector machine algorithm. So I simply search suppose support vector machine algorithm, vector machine or SVM algorithm. Simply search. So if you get this type of thing, then you can easily identify. Suppose you can see it's a support vector machine algorithm, and in this algorithm, if you check, we can easily classify the two class. Suppose this is the deforestation class and this is the forestation class. So not only for that, any problem or any classification, when you classified only for the two class, then support vector machine is more better one, because support vector machine is two for classification and regression. Both of things we can just apply, and we can see this is the decision plane. This is the decision plane, and separate the two class. This is the green. This is the suppose another. Suppose this